Alright, welcome back. Today on my bench I have a Harman Kardon HK 725. This is an ultra wideband stereo preamp. eBay junk. Let me make that clear. I've gone through, just to save time, I've gone through and did some testing on this piece already. A few notes here. High cut. Actually, here, let's take this off. That's just to hold the knob on. See, the knob is... I need to address that. There's a set screw. But I just didn't want to lose that. But anyways, let's go through the through my list of defects that I found so far. High cut. When I hit the high cut button, the left channel drops out. So there's something wrong with that switch. A lot of these switches are dirty and need cleaning. You can see there's kind of, I don't know what that is. I'm gonna have to, like, something's corroding these buttons. Maybe it spent time outside. These buttons appear to be plated with some kind of a metal, and there's corrosion. There's corrosion on all these buttons. Scratchy Pots. Okay, we got the volume pot is scratchy and the balance pot scratchy, and we have stuck buttons. And you can see this. That one doesn't work. That one sticks in. That one's... See, when I some of these buttons are stuck in, and when I press another button they're supposed to pop out. There, that one popped. This one's still stuck. These ones don't even catch. See, the mechanism inside is not catching, and they're not sticking. And we have the same problem. These buttons are all messed up except for the defeat buttons. The defeat buttons work. Balance pot. This volume pot. You hear that? That sounds terrible. So we're going to have to take the potentiometer apart and see what's going on with that one pot. It might need replacing, or it might just need to be fixed. I did test the preamplifier with a source and another amplifier, and it does work, but one channel will fade in and out at random times, and it will go quiet. So I expect there's going to be some cracked solder joints in here. I expect to see, well, the corrosion's messed up these switches. We'll see what we can do about that, and then we'll see if we can get this working good again. I expect it might need a full recap, but let's take the lid off and have a look inside first. Okay, screws are out. This off. Looks fairly good. There's been some heat on this area, which is directly over top of this power supply. Let's see. So it's a nice design. Not seeing anything really critical. I'm seeing some stuff here with the conductive glue. We have some conductive glue in a few spots on this board. Mostly right here around the power supply. We got conductive glue. Got a couple of heat sinks, probably voltage regulator, transistors. So we've got some caps in here that are probably roasted, so we're going to go through and we're going to check all those caps. Not that many caps on this board, maybe a full recap. Maybe. We'll see. I'll see how they test out. But we're going to go through and we're going to check a lot of these stuff, the switches and things. The high cut switch is over here on this board. I'm going to see, these switches are replaceable. They look like they can be replaced. standard size switch. I'm going to have to take this all apart and figure this out. Oh, now it's working. This one's not. So we'll go through and we'll do a full service on this. It's a nice unit. I wanted to get, I got this preamplifier and I have another preamplifier waiting in the wings to be serviced. I want to get the preamps done first because I have some power amplifiers coming and I want to have these ready to go before I start servicing the power amps. So let's finish. I'll pull the rest of this front panel off, and looks like everything's accessible from the top. There's nothing happening on the bottom. Phoenix Hi-Fi. Shillington, PA. So we'll pull this off and we'll continue on. Okay, so I've done some disassembly and I'm already starting to run into problems here that I can see. First of all, there's two burned out lights for the tone defeat buttons. When you hit the tone defeat, this light's to come on. Hit that one, this light's to come on, and that tells you that the tone is set to flat. The buttons, now that I removed them from the case, are starting to behave normally. Even this one. So that tells me something was not right with the way it was mounted, or maybe it was stressed or twisted. So I'll have to go through that. I'm also running into cracked solder joints on some of these switches, just from the use and the vibration. Some of these are cracked. These ones are good, but there's, I think one of these is cracked, and then on the underside some of these are cracked. So what I'm going to have to do is remove all these switches and disassemble and clean all of these switches independently, put them all back together. I could replace them at a cost. I think, you know, there's 16 switches here that need to be replaced, but I think I'm going to leave that for now. I'm going to see how they clean up, and the resoldering, I'm going to see how that goes. More switches here, back here, more switches here, and I think I had some cracks on these, This here is a big problem. Well, I'm going to zoom in so maybe you can see. Somebody gooped hot glue, conductive glue, all over this board, and it dripped down. And a lot of these, in behind these capacitors, is all corrosion. There's corrosion going on here. This has to be all taken apart and cleaned. There's corrosion going on here. Some traces look like they might be eaten away. So I'm going to go check all that out. What else? I still haven't done the ESR of the caps yet, but I think I'm just going to end up replacing them anyways, because I think in the end that'll benefit. I don't have bipolar caps. Some of these are bipolars. There's a cap up here. Here, let me zoom out again. All these switches will have to be cleaned. I still haven't done the ESR on some of these. I checked a few and they were high. I'm just going to go through and recap. There's not very many caps on here. Some of these are bipolars, like these ones. These are 470 at microfarad 10 volt. They're bipolar. I got a 16 volt 47 microfarad bipolar. Here's another bipolar here. 10 volt 47 microfarads. I might have to order up some bipolar caps. I don't normally carry bipolar caps here, but the rest of them are pretty standard affair. So we'll get through this. I still have to do something with this volume knob. It's got an awful scraping noise in it. You hear that? It sounds awful. I think somebody might have had this apart before in an attempt to clean it. I'm not sure. But I'm going to have to open this up and see what's going on with that. Maybe it wasn't put together properly. Maybe it was damaged. So it is working, which is a good sign. So we'll get started on this. I'm going to have to remove a lot of these switches. Like these need to be removed. I don't think I need to remove these ones. These ones will definitely need to be opened up on these two packs here, so that I can get in and clean the switches and make sure all the solder joints are good. So it's coming along. Well, I haven't even started yet, but we're finding out lots. Okay, so I'm just working on this board here. I removed these two caps because they were just in the way, and I wanted to get this cleaned up properly. I've been going around scraping here, and I have a feeling I'm missing some traces because there's a lot of corrosion going on with the copper traces, and this glue was just poured on and it went all between the different solder joints, and that's the worst kind of scenario you want because all that glue is conductive, and as soon as you get a conductive component on a board where you got current leakage, you're going to start getting corrosion. That's what corrosion is from, actually. It's galvanic action. But I'm just going to try and clean this up, and then we'll inspect and see how bad it is. But for the most part, a lot of this looks intact. I think I have one trace down here that is corrosion. And the rest of them look okay. It looks like the solder mask held up. I'm just going to make sure I'll clean this off good. I'll get some alcohol in here. And then I'll test those two capacitors that I took off. Make sure that they're not damaged from the corrosion or the glue itself. And then I'll resolder all these joints. Some of them look kind of questionable, iffy. So I'll go through and do that. This switch on top here is the high cut filter. And now that I look at it, this joint is completely cracked. Let's get a look at this again. Yeah, this one here is completely cracked. These two are cracked as well. This one's cracked, and these ones are intact. So that's probably the reason why we were getting one channel dropout when we were activating this switch. So I'll solder that back up. I'm still working on this circuit back here to get it cleaned up. I have circuit glue mixed in with the solder and the flux, and I'm having a hell of a time cleaning this all out and getting it to reflow when I'm hitting it with a soldering iron. It's just not working the way I want it to. So I'm going to continue working on this and get this 100% before I move on. Okay, more conductive glue problems. I removed the 4 capacitors here just to get in there to scrape all this stuff out. And it's just in there, and that actually it bled through from the top of the board onto the underside, so it's causing damage under there too. I got this all cleaned out. I still have to, this capacitor here is it's got glue underneath it. I'll have to pull it, make sure it's free of glue. And then I have a problem here with these two transistors. These are FETs, high impedance FETs, and this one here is all completely gopped around with that glue, and there's a Zener diode in there, I think it is, and it's got corrosion on it. And then this FET over here, the leads have corrosion on them. I'll have to dig out all that, make sure that those two FETs are okay. Capacitor is actually surprisingly good, considering I thought these would be cooked from all the heat, but they're not bad. I pulled out these two are good. These two are borderline. I'm going to put new ones in here anyways because they're in direct firing line of all the heat. And these ones, I could upgrade these to 1000 microfarad. These are 470s and 50 volt cans. You notice how big they are for 470, but I can remove those and put 1000 in there just to improve it maybe a little bit. I'll still check some of these other caps. I still haven't checked any of these yet, so I'm finding problems, and I think when I'm finished, I think they're going to be all corrected. So, all right. So here's one of the switch gangs for the tone controls. I don't know if this is bass or treble. I think it's bass. But you see how this works. There's 4 switches on this side, and then there's 4 switches on this side. This center switch is independent. It has its own latching mechanism. But these 4 switches and these 4 switches operate together in a gang configuration with a locking bar that's hidden. You can't see it in here right now. I'd have to take it apart. What I'll do is I'll disassemble, pull out a couple switches, and I'll show you this locking mechanism. And for the most part, it's got to be freely moving and not binding on anything. If there's any dirt or anything that was in there, it will mess it up. So I can pull this switch out. And you can see this switch here. Oops. Put that back. Ah, it fell apart on me. Okay, I'll have to fix that. But you can see the action of the bar in here with the remove switch. And when I press one of these switches, what it does is it pushes on the bar and releases the other switch that was locked in. And if I can get it here, you can see there's a latch here on the side of the plunger, and that's what locks in the switch. Okay, so these are all silver contacts, by the way. You can tell by the tarnish. You got tarnish on the silver, starting to tarnish, turn black. See here. So these are all cleanable with just spray. Okay, let's put this back in. So if one of these does come apart on you, don't freak out. It's not the end of the world. You just put it back together. But now that I have this out, I can take this and clean it. And what I want to do is I want to clean the bar itself, because it seems like the bar is binding. The bar is not moving freely, and it's not releasing. The more I played with it here, the better it's working, but I just want to make sure that that bar is clean. I'm going to pull out some more switches here. And put this back in before I have another. There's a little bit of screwdriver action to pry upward. Okay. And you can see the action of the bar here. Looks to me suspiciously there's something here. I don't know what this is. It looks like It could be something gumping it up. And then there's a spring. I'll show you the spring, where the spring is. The spring is right here. I don't know if you can see the spring in there. See there's a little spring? That's what keeps the bar pushed to the left. So if I take this one apart right now, the spring would pop out. Yes, it would. Let me take out the other ones first. I'm just going to put you on pause. I'm going to remove the other switches. Okay, so I got all the switches removed except for one. And now you can see where the spring is in there. And the action of the bar, the release bar, is just to slide back and forth like that. And you can also see that the bar has a notch cut out for the center switch, because the center switch is independent and we don't want that gang action on that from the bar affecting that switch. So let's take this last switch out. These switches are all replaceable. You can still buy them. I'll show you here in a second. They all come with the basic same switch body, and then you just configure them the way you want them. Well, let's take this out first. Let's see if we can get this out without blowing parts across the room. I don't want to lose that spring. That's just the problem. So let's, oops, I don't want to do that either. Stay in there. Okay. Okay, there's our spring. Oops. And there's our bar. There we go. Okay. It looks like there might have been something here that was... I don't feel any lubrication. It's dry. Let's give it a clean with alcohol, and then we'll lubricate it, and then we'll put it back together. Some of these switches have this. I don't know what this is. This is some kind of contaminant that got into the switch. And it could be soda pop. It could be anything. You don't know. But it looks like it got in through the front. This one has it too. Let's have a look at this one. You see that? Whatever that is, it might be causing something to stick. I'll try removing it with alcohol. I'm just going to look at another one here. See, that one's clean. And it's clean in here too. So a few of these switches had some kind of contaminant that may be causing a problem. Alright, so assembly. This bracket has the two threaded holes. That's the front. That goes to the front of the switches. So this is the back. Okay, I think we've got it finally. So the spring's in, the bar is on, and we're going to put our first one on. First one's the hardest. Once we get this one on, we'll be laughing. There we go. Okay. so it's working, the mechanism. What I'm going to do is I'm going to lubricate this with some silicone. And just going to give it a mainly looking at getting the bar a layer of silicone lubricant, just so that it doesn't stick. Okay, I'm going to squish this one, squish this one. Okay, that's which is in there. So let's start populating the other ones. I got another one here. Let's go on the other end. Okay. It's working normally. Everything's good. Okay. I'll put this aside to reinstall, and then I'll pull out the other one. Alright, so I'm desoldering these boards and I'm pulling the other bank of switches out. And I just opened this up. I just want to show you what I'm finding. Look at all this stuff, whatever this is. I don't think it's rosin flux. I think it's something else. And it's all over the switches too. All the switches have this. I gotta clean all this crap out. It might be flux, but that's not very good. You don't want to get that flux into your switch mechanisms. It'll just gum everything up. And you know, let me take a little bit of alcohol here. Yeah, I think this is all just rosin flux. I'll have to clean all this off. It's good. It's very sticky, but we'll get it fixed up. Okay, let's tie into this volume pot. I got it removed. Let's see why it's making a scraping noise. Doesn't sound good. Put this back. Wondering if maybe it's just... Okay, well, let's take it apart. If we can open it up and see. I think somebody's been in here before because it's... Those screws look like they've been just about stripped. And it should just come open, one would think. There's a... Oh, it's pot metal. Okay. It doesn't look like that's going to come. I would have to take out this this press-on nut to go any further, and I don't have a new one. If I had a new one, I could take this off, destroy it, take it off, and then do my work. Doesn't sound good at all. Why is that? Well, let's get some deoxit. I have a feeling there's a track here. This is the common track. Making scraping noises. I'm going to try this on the inside one too. Come on, give me a bubble. I can imagine what it would cost to replace one of these pots. It must be pretty high. Okay, let's see. We got a bit of a cleaner in here and see what we can pick up. Here's some alcohol. Yeah, there's some carbon right at the end of the track. Let's see if I can get some on the other side. Well, I think what I'm going to do is I'm just going to deox the crap out of these contacts. We've got these two here that ride on the center ring, and that's your common. And then you have your two outside, and then your tap. I think I'm just going to deox all these contacts. Because I think they're dry, to tell you the truth. Let me try cleaning this one. Maybe I can't. I can't clean that one. It's like I can't get into it. No, can't get in there. I'm just going to deox everything and be done with this. Okay, and then inside. I think I got everything. I don't want to do anything more. It's definitely a nice potentiometer. Is this made by Alps? Yeah, it helps. Here's your part number. It's a 100K pot. It's not a cheap unit. This is a very high-end pot, especially when they start making cast metal housings. Looks like I might need more. Okay, short of replacing it, well, actually what I could do is I could find these nuts, these press-on nuts, and disassemble it fully, but I'm not going to gain anything more than what I'm doing right now. I'm just going to reassemble this and put it back together, reinstall it, and we'll see how it performs. I have a feeling it's good now. I don't think it's going to give us any more problems. So we'll just leave it at that. And if it still acts up, I guess I could look for a replacement. It's not a big deal. It's just a 100K pot with the volume tap, and I think they are easier to find, and I wouldn't be able to find a nice fancy one like this, but we will see. Okay, I'll reinstall this. It does sound better. It sounds a lot better. I think while I'm here, let's give it a really okay, I'll let that oil soak into the shaft, and then get rid of the excess. I think we're good on that. I'll reinstall that. So I'm looking at these switches, and I'm pretty confident that the rosin flux got into these switches. You can see it here. And I think this is what's causing the switches to stick. I'm not sure. I'm going to clean all this stuff out. You can see it here. And I'm going to clean all these switches. I got 28, 26 switches out right now. I got piles and piles of switches everywhere. I'm going to take them all apart and clean them. It's going to take me all day. But this, I think, is what the problem is with a lot of these switches. Especially these gang switches. These ones. This one I took apart and cleaned already. But I think that's was wrong. A lot of flux got in here and messed up a lot of things. So I'm just going to take my time, clean this all apart, and put it all back together, and then I think we'll be good. Okay, I know it looks bad, but you're probably wondering why the hell did I go through all the trouble of removing all 28 switches and take them apart and clean them individually. The quick answer is because a lot of these were contaminated with flux, and if I just went ahead and sprayed stuff in from the outside, I'd probably be washing that flux into the switch itself and interrupting a circuit. So what I opted to do is I removed all the switches, I disassembled the gangs, and I disassembled each individual switch. Spent about 5 or 10 minutes cleaning each switch, taking it apart, cleaning it, make sure there was no flux inside, and then lubricating it with some deoxit. And I did that for every switch. So, you know, it took me all day. It was a tedious job. It was boring as all hell, but it's done, and everything. All I gotta do now is start putting things back together. I went through and replaced 2 capacitors in the power supply that were bad. The rest of them I checked, they were all good. Haven't looked at it for cold solder joints or cracked solder joints, but I don't think there are any. But I'll go over it once more, and then it's just a matter of reassembly. And then after that, I think we're done. Just a little note, there's one thing that I forgot to mention that I still need to do. I have 2 light bulbs. These 2 light bulbs here that are burned out. These are incandescents, and they have a little green condom on them. So if I pull this condom off, yeah, you can see they're burned out. So I'll change those as well. I'm thinking I'm going to stick with incandescents instead of LEDs. I'm going to check and see what voltage these bulbs run on. There's really no mention of it in the schematic. Let's check here. B+3. And it's through a 1K 1 watt resistor. And from B+3, I haven't measured any of these voltages yet, but I'll check what B+3 is, plus B3, and that's a voltage that supplies voltage for these 2 lamps. I haven't really looked at the service manual in any depth, but I'm looking at this and I'm wondering why in Harman Kardon's wisdom did they decide to go with these switch gangs instead of just putting a potentiometer in. And I really can't come up with an answer other than just to get away from using potentiometers, because they tend to go scratchy and cut out over time. But then switches are no better either. You know, 20 plus years or 30 years, these silver plated switches, they all oxidize and they go flaky as well. So I don't know. Yeah, I'm really at loss as to why they did this. I think it was more of a gimmicky thing. You know, I don't know. If you have any thoughts on that, let me know. But it's all cleaned up now. It's going to be working 100%. It seems like a lot of complicated rigmarole just for, they could have just put in 2 pots and been done with it. But then I guess it wouldn't have made it as special as it is, and they couldn't have charged the price they did. You know, overall it looks like a well-designed preamplifier. It's got a nice power supply section. It's got, you know, a nice phono section. But yeah, I don't know. I'm kind of lost as to why they did that. But we'll get it going. Alright, service bulletin time. The HK 725 has a service bulletin, and it's dealing with hum from the headphone jack. There is a ground loop, I think. It says, due to tolerances in the ground plane of this model, a 50 or 60 Hertz hum can be audible in sensitive headphones plugged into the headphone outlet on the front panel. This hum can be eliminated by a following modification. And it's a grainy picture, but I get the gist of it. They want us to cut, there's a ground trace that runs along the outside here. They want us to cut the ground trace and then put a jumper wire from here to here. Yes. Now the procedure they showed has you doing it from the top of the board. With the board installed, you got to take a hacksaw, cut the edge of the board here, and then test with an ohm meter, and then install the jumper from above. But I can do everything from below because I got the board out. So what I'm going to do is I'm just going to take a Dremel and I'm going to just cut the trace. Okay, that trace is gone. Then with an ohm meter, continuity tester, test to make sure that there's no trace of connection. There isn't. Okay, now we need to install a jumper. Piece of wire here. Let's start with a fresh end. So I need a piece that goes from here up to here. Okay. Since we got it open and apart, might as well do it. There. Now I guess that takes that ground from here. I guess there's a sensitive part here. This comes from, this part here, right here, comes from the transformer. These three wires. These are AC, AC, and that's the center tap, I believe. And that's your ground plane for the entire, if you look, it carries throughout the whole board. But that's cut, and that's in place, so we're done. Alright, we're coming up to the finish line. I'm going to deal with these buttons. Looking at them, they don't look good at all. I'll show you one or two. You can see on the sides they have kind of a crusty. What that is corrosion, because there's green in there. These are plastic buttons, but they have a, I think they're nickel plated, and they do have a metallic coating on them. And I believe something is attacking the nickel and turning it green. Could be the acid from fingers, I don't know. But I haven't seen it this bad. Maybe this preamp came from a maritime environment, I don't know. I'm just guessing here, but what I'm doing is I'm taking alcohol and just wiping them down. It doesn't really stop the corrosion, but it gets rid of the kind of chalky white, and I think this is part of the reason why the buttons were sticking in the first place when I first had tried out the preamp. These are replaceable. You can get them, I guess, if you go through Harman Kardon, or if you can salvage them from another unit. But what I'm going to do is I'm just going to clean them off best I can with some alcohol. Usually when you get somebody spills pop or something all over a piece of gear, the acids in the cola or soda or whatever you had will attack any metals. So you got to get that stuff out. I don't think this is anything like that, because usually with a soda you get a really sticky residue. Another thing you got to remember to do is take a Q-tip alcohol and clean these holes, especially if you have a spill. You got to get all that stuff out of there. These ones aren't bad. They were pretty much clean, which tells me that there wasn't really a spill on this. It was probably more just corrosion on the buttons themselves. These are all pretty clean, but you got to make sure they're clean before you reassemble, or otherwise you might get a button that's sticky. Okay, so look what happened. I broke the power button off. It's putting the front panel back on, and I was fighting with one side. I couldn't remember. One side wasn't going on. I was fighting and fighting, and finally it went, and then it snapped this off. My mistake. What I should have done is I should have Should have pulled these two screws out and take the power switch off, because here, let's do that right now. And then I could take the power switch out and I'll put this back together there, and it wouldn't have got damaged. And I don't know, there's glue on this. I don't know if it's been broken before or if they glue them at the factory. I think they glue these knobs on at the factory to keep them from falling off. But we're going to fix this. What I plan on doing is, if I just glue this back on again, I'm pretty sure it's just going to snap again anytime, you know, you get any sideways pressure on the button itself. It's just going to snap off. What I'm going to do is, here's what I've done. I went through my machine screws and I picked out the skinniest screw I could find. And this one measures out at, I think it's a 2 mil, but it measures out at 1.9 millimeters. And it's a coarse thread. I don't think it's a machine thread. I think it's a plastic thread. But we're going to drill, we're going to pick the appropriate size drill bit for this, and we're going to drill a hole in here, and we're going to drill a hole in the, where's the other part? Yeah, we're going to drill a hole in here, and then we're going to use a chunk of this as a shaft to go between them and provide some rigidity, and we're going to epoxy it all together, and it should not have any more problems with it in the future. So I'll get the bits going here and just drill a hole. So since this is a plastic thread, I think what I can do is I can undersize the hole by, well, this is about 1.5 mil, and then the overall is 1.9. So I think if I go with 1.5 millimeters, I can, that's too small. I can drill the holes, thread that piece of, no, that's still too small. Let's find this right size. There. We'll use this bit, and this is a number 53, 59 thousandths of an inch. What I'll do is I'll drill this, and I'll drill this, and then I can epoxy it up. I can cut off a chunk of this, probably 10 millimeters or so, thread it in there, and then thread that piece on there, and then let it set up, and we're done. Make sure we're centered. Worked pretty good. Okay, that's gonna work good. That's got a nice tight grip on the plastic. So we need to drill another hole here. And try and get this as center as possible. Okay, I got it deep enough there. That's probably about 8 mils. Yeah, I'm gonna cut it right about here. I hope it's not too long. Let's cut this. So now I got a little chunk of threaded rod. Actually, I should have threaded it in first, but that doesn't matter. What I'm gonna do now is mix up some epoxy, and then we'll slop this thing together. Okay, I just want to take this little blob of glue off here. So I think it's going to be, there we go. It's brittle anyway, so let's get Okay. It's pretty secure there. I got way too much. There we go. And then the last step is to make sure it's aligned with the power switch. So that's good. And just let that set up. And hopefully that'll hold. Seems to be a weak spot for these Harman Kardons. I had an HK 460 that had the same kind of button set up, and I think somebody glued it. I'm not sure. I mean, it could be factory glue too. I'm not 100% sure on that, but I'll let that set up, and then I'll reassemble, and hopefully it'll stick together. All right, so we got everything back together, functioning. Let's go do a few tests. All I can do is run a signal through the amplifier or preamplifier and see if we get a clean signal. I'll test the treble bass controls, everything else. I got my scope set up for 500 millivolts division, and I'll start turning it up. I'm feeding it at 1000 hertz right now, and you know, everything's working 100% here. So far that I can see. I'm just going to turn that to see what kind of a peak signal we're getting. Left channel is 3.22 volts. Right channel is 3.11 volts, so it's a little bit less, a little bit weaker on the right channel. Distortion free as far as I can see. Everything looks good. Okay, so let's turn this down a bit, and then we'll readjust this so we get a good picture of what we're looking at. Okay, so let's turn this down to let's go on the low end of the frequency spectrum here. Let's go 100 hertz, and a nice clean signal. Let's try the bass controls. I'm at +2 right now, +4, +6, +8. Everything's working there good. +2, -2, -4, -6, -4, -4, -6, -8. So everything seems to be okay. Tone defeat. That's working. Okay, that's good. Let's try subsonic. Has no effect. Let's take off the... Okay, we're not getting anything. Let's turn this down to 30 hertz. 20 hertz. Get a nice clean signal. Subsonic. There, it cuts out 20 hertz quite a bit. Let's try it with 10 hertz. Subsonic. Really cuts it out 10 hertz. Let's turn this down to 5 hertz. And we'll see what the subsonic does. It should pretty much remove a 5 hertz, which it does. Substantial cut there. Loudness increases the bass. Let's get this back up. 15 hertz. Loudness, everything's working good. Tape monitor cuts it out. Okay. And these are tape dubbing controls. I'm assuming they work. Tuner. Okay, everything's good. Everything's good on the bass side of things. Tone defeat. Perfect. Everything's working great. On the low end, let's try the high end. Let's try 10 kilohertz. Kilohertz. Okay, we're at 10 kilohertz. High cut. Seems like the left channel is more cut than the left. That might still be a defect in the preamp, because I know I had one channel cutting out before on with the high cut. We'll get back to that. Okay, let's try +2, +3, 4, +6, +8. Everything's working. -2, -4, -6, -8. Everything's working. 100% here. Defeat. Yes, it's working good. Let's go back to 1 kilohertz. Okay, this high cut has me concerned. That's a problem. We lose the left channel when we high cut. That was the spot where I had the circuit glue all over the printed circuit board. So we still have a problem there. We're gonna have to fix that. Okay, so here is the schematic for this amplifier, preamplifier. Shut this off. We have our outputs here. Let's go backwards from the beginning, from the end. And then the relay that cuts out the signal when we shut the machine off, and this is the time delay for turning it on. So left channel comes back through here, and the signal comes from here, and it goes to the headphone amplifier, and it goes to the output. Right? That's where it splits off. Output, headphone amplifier. So this line here goes back through 100 ohm resistor to the center pole of this switch. And when the switch is in the off position, everything's working fine. So off position, we're getting a signal through here, through here, through here from this amplifier. So we know these two amplifiers are working great. We went through all the steps with that. And then as soon as we turn on this high cut filter, it's an active filter with a transistor circuit. And when we activate this switch, we're now taking a signal from, instead of from here, we're taking the signal from here. And we're getting it through here. It goes through this high cut active filter, and then it comes out through this 330 ohm resistor and out. So I have to check all these parts: 33K, 47K, this transistor. And I remember checking this transistor. It is good. This here, I believe, is a power feed. Yes. So I'll have to check this one. I'll have to check all these parts here. This 330. And then I'll have to be suspect of this capacitor. So I'll go through and check all these parts and see why we're losing our high cut when we switch to that position. And I'll make sure everything's working here. Okay, here is, I think I found the problem. This printed circuit board, it's got corrosion on it from the conductive glue. If I check between this one, I got a continuity there, continuity there. If I check this trace, I got nothing. Nothing along this trace at all. From that side, from this side, yeah, so that trace is gone. I'll add a jumper in there. Alright, back together again. What I did is I installed a jumper wire over that bad trace. You can see it on here. A little tiny blue wire. And we should have continuity now for our signal. Let's test this one more time. Final time. Let's hope. Wait for the relay to click in. There it is. Turning it up. Got both channels. And I'll hit the high cut. There. We still have both channels on high cut, so it's working now 100%. So everything in this preamplifier is working and fixed up. So I'm going to put the cover on. I have one power amplifier I want to work on next. It's a doozy. What I want to do is go through it and do a restoration on it because it is a vintage unit, and we'll use this for testing that power amplifier, and we'll see how that goes. I still don't know about their button system though. I just don't get it. I think it's more of a, I don't know. Anyways, we'll leave it at that. Pots are nice and clean, no scratchiness. I didn't check the balance. Balance is working good. So everything's good. We're going to leave it at that. Alright, thanks for watching.